Okay, so our set here is that s equal to 1 comma 2 comma 3 up to so on till 2n, right, where n is some positive integer, and that we are selecting, and of course cardinality of s is then 2n, and now we are selecting n+1 positive integers from this set, right? The numbers that those are a1, a2 and so on till an+1. Okay, and the claim is that there will be always two integers. Okay, whatever way we select, so this set, whatever way we select, okay, there will be always two integers in that collection of n+1 numbers, such that ai aj, there will be always two numbers a and aj, where such that ai divides aj. Okay, that's what we are going to prove, and we are using pigeonhole principle to prove this. Okay, so let's state two facts first. Let's say write fact 1 as fact that the cardinality of s is 2n, right? The set is 1 to 2n. So how many odd numbers are there and how many even numbers are there? So number of odd numbers is nothing but n, right? Similarly, number of even numbers is going to be n, right? This is some simple fact just I stated. Okay, now second fact. Okay, so anyway, I mean these facts we are using in the I mean our proof, so that's why I'm just stating it. So the fact 2 is that any positive integer, or in fact any integer ai, can be written as power of 2 into an odd number. Okay, so ai equal to 2 to the power ki into qi, where ki is basically at least 0, and qi means it's an odd number. Okay, qi denotes an odd number. All right, integer you take out all the factors of 2. Okay, and then what will be remaining is an odd number, right? That's it. So let's see some examples. So for example 40, we can write it as 2 to the power 3 into 5, right, where 5 is the odd number here. What about 36? 36 we can write it as what, 2 raised to 2 into 9, right, where 9 is the odd number here. And what about 9 itself? 9 we can write it as what, 2 raised to 0 into 9, where 9 is the odd number, right? So in this way we can actually write every integer in this format. This is another fact that we are going to use. Okay, so let's suppose that whatever a1 to an+1 that we have selected, okay, from the set, we are writing it in this form. Okay, now since I told that we are using pigeonhole principle, okay, now we have to find out the pigeons here, and we have to find what are the pigeonholes here, right? So what could be the pigeons? What, a1 to an+1, the numbers that we have selected, right? That are the pigeons. What are the pigeonholes here? We told that each ai we are writing it as 2 to the power something into odd number, right? So whatever, so corresponding to every ai there is an odd number, right? So the set of odd numbers form the pigeonholes. Okay, corresponding to each ai, right, we have odd numbers, because each ai there is this qi, right? So this mapping, so pigeons are ais, and the, right, so the pigeons are ai, and pigeonholes are this odd numbers qi. Okay, now what, yeah, so how many pigeonholes are there? So number of pigeons here is n+1, right? And what about number of pigeonholes? Can be at maximum n because of our fact 1, right? Because of this fact we have the number of pigeonholes as n. So there are n+1 pigeons mapping to n pigeonholes, so we can apply the pigeonhole principle, which implies that there exists at least two numbers, right? So ai and aj, which have same. So here qi, so it is 2 raised to ki into qi, right? And here aj is 2 raised to kj into qj. So here what it means that qi is equal to qj, right? Because of the pigeonhole principle. And let's say that is same as q. Okay, so we can write it like this. So ai is 2 raised to ki into q, aj is 2 raised to kj into q, right? Now we don't know, we have this a and aj. Now we don't know whether ki is greater than kj or ki is less than kj, right? So let's take both cases and then our proof will get completed. So if ki is less than kj, which means that ai is less than aj. Okay, and then what it means is that ai is equal to 2 raised to ki into q, aj equal to 2 raised to kj into q, right? So if ki is less than kj, okay, then it means that ai divides aj, right? Because aj divided by ai, we have remainder 0, right? Because q gets cancelled. See what is aj divided by ai here? That is going to be 2 raised to kj into q by 2 raised to ki into q, right? So q get cancelled, and this will be something 2 raised to kj minus ki, right? So if ki is less than kj, right? If k is less than kj, then this makes sense. Okay, so that means that here ai divides aj, all right? And if ki is greater than kj, the reverse. If ki is greater than kj, right? If ki is greater than kj, aj divides ai. Okay, you can verify it. I mean, it's the same reasoning. Okay, so that, hope this is clear. So hope to see you in the next video. Thank you.